Alright, so we're going to continue with section 2.5. We're going to try to finish it up in this video. So we've talked about using slope and point slope form and writing equations and using the slope formula and all those things in the previous video. So now we want to continue with writing equations, but this time we want to write an equation of a line through 2 points, and then we want to put that equation in slope-intercept form. So what you'll notice here is that, again, we don't have the slope. And we said in the last video that to be able to graph an equation, write the equation of the line, we have to have the slope. And so we're going to start by finding the slope. Again, the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which in this case is negative 2. And so again, that minus and negative does make that positive. And so 2 minus 4 is negative 2. 2 plus 2 is 4. That does simplify to negative 1/2. So there's the slope that we're going to use to write our equation. Now, I told you in the last video that you can use either point. It does not matter which point you use. I'm going to use this second point. The reason is because both numbers are positive. Obviously, the 2 is smaller than the 4, and so it's going to make my work a little bit easier dealing with smaller numbers. And so we're going to take that point and now the slope that we found and substitute it in to the point slope form. And so the point slope form says we've got y minus y sub 1, which is 2, equals our slope, which is negative 1/2, times x minus x sub 1, which is also 2. And then we want to take this and we want to write this in slope-intercept form. Now, there's only 2 steps left. We're going to distribute the 1/2 and we're going to add the 2 to both sides to get y by itself. But because we're dealing with a fraction here for our slope, that sometimes becomes difficult for people. So let me just kind of walk you through how this is going to work. First of all, we're going to take this negative 1/2 and we're going to distribute. So when we do, we have y minus 2 equals negative 1/2 x plus something. Now, you maybe can do this in your head without a lot of issues. I hope you can. If you can't, you have a calculator. Take the negative 1/2, put that in parentheses, and multiply it by negative 2. And you'll see that you're going to get positive 1. Now, somebody says, well, how do you get that 1? Well, negative 2 is the same thing as negative 2 over 1. And if you were to multiply straight across, you would get 1 times 2, and then on the bottom, 2 times 1. And so you have 2 over 2, which is 1. And because both numbers are negative, negative times negative is a positive. And so that hopefully is not a huge problem. Just kind of as a side note, here's what's happening. We're taking this negative 1/2 times negative 2. Again, I like to think it as being a fraction. And then when you multiply straight across, you get 2 over 2, which simplifies to 1. That is where that number comes from. Okay? Then our last thing is to just add 2 to each side. And so negative 2 plus 2 is 0. We get y is equal to negative 1/2 x plus 3. And so there's our equation in slope-intercept form. Now, if this number out here ended up not being a whole number or an integer, if it had been a fraction, let's say 2/3. Okay, just kind of, again, as a little side note here. When we go to add this 2 in this step, when you add, if you were to add 2 to the 2/3, you would need this 2 to be a fraction with a common denominator of 3. And the number on top of that fraction would be this 3 times the 2, which is 6. Because 6 over 3 and 2 are the same thing, right? And that would allow us then to add 2/3 and 6/3 if we needed to do that. So if this number ends up not being a fraction, if it ends up being a fraction, not an integer, then you may need to take this out to the side and add. In this case, if you were to add 2/3 and 6/3, you would get 8/3, adding the number on top, keeping your denominator. Again, your calculator will do that for you, but that's something that you could very easily see in your math lab. And so when you do, there are going to be people that really struggle with that. And so I want to make sure that you understand what's happening there. If you have any questions about that, again, feel free to contact me and let me know. So let's kind of clean up a few things here as we're trying to wrap up this section, this chapter. We want to, first of all, when you look at an equation of a vertical line through a particular point, remember that a vertical line goes up and down, and it has an x-intercept but not a y-intercept. And so when we write that equation, we're going to figure out, well, what's that x value? And the equation is going to be x equals whatever that number is, whatever that x value is from that ordered pair. And so you could choose any point on that vertical line, and they're all going to have the same x value. And so, as we've talked about previously, if our equation is x equals a number, well, it's got to be vertical. And so, if we have a vertical line through a particular point, then our equation has to be x equals whatever that x-intercept is. On, this should say horizontal. I cannot spell today. Horizontal. If the line is horizontal, then our equation is y equals some number. Okay, so if we're looking at this ordered pair and the line's horizontal through that point, well, it has to be y equals whatever this b value is, because again, it doesn't have an x-intercept. It only has a y-intercept, and so wherever that y-intercept is going to be the same value as this b. And so our equation becomes y equals b. Now, that kind of leads us into the next part. We've talked about slope a good bit and writing equations. And so we need to talk about parallel and perpendicular lines. So two distinct non-vertical lines are parallel if and only if, that's what this IFF stands for, if and only if they have the same slope. It also means that if two lines have the same slope, they have to be parallel. And so it's important to understand what parallel lines are. And normally in class, I'll ask the question, what are parallel lines? And I see people start doing these hand motions where they look like they're directing airplanes or something, doing their hands together up and down, side to side, whatever. And while that's sort of humorous in class, I get what they're trying to say. They're trying to tell me that two lines that run side by side are parallel. And yeah, that's true, but specifically, they can't intersect. It's two lines that do not intersect. And when that happens, those lines had to have the same slope. And I think I can probably convince you of this, because if you were to take a point on this line and you were to go up some amount and over some amount, that rise and run, and do the same amount here with this line, the amount you go up and the amount you go over is going to be the same every single time. And so neither line is going to get closer to each other. And so when we talk about lines that are parallel, well, they have the same slope, because you go up the same amount, over the same amount, up the same amount, over the same amount, and so on. If you were to look at a staircase, for example, if in my classroom at school, it's on the top floor, right? And so if you were to go up the staircase, you would have a set of stairs here and a set of stairs here. And those staircases should be parallel. Because if they're not, at some point, the staircase would run into each other, which obviously would not be good. And so we can see that that staircase is parallel. Those two sets are parallel because the size of the step is the same. They go up the same amount, they go right the same amount. They go up the same amount, they go right the same amount. And so because that rise and run are the same, that ratio of how much it changes vertically and horizontally is the same, they never get closer to each other. And so therefore they never touch, and so they are parallel. Now, if two lines are perpendicular, so first of all, what does it mean for lines to be perpendicular? And again, typically I ask this question in class, and I always have people that say, well, they cross. Well, yeah, that's true, but we need to be more specific. And so let me give you an example. This line and this line, for example, they intersect, but they are not perpendicular. They cross at this point, but that's it. However, this line and this line, we may say are perpendicular because they form a right angle. Now, that's just a sketch. It's not perfect, but any line that is any lines that are perpendicular have to form a right angle. And so how do we guarantee that happens? Well, we have slopes that we call opposite reciprocals if two lines are perpendicular. What that means is when you multiply them together, you should get -1 as the product. So, for example, if this first line has a slope of, let's say, 3/4, then if it's perpendicular to this other one, it better have a slope of -4/3. Because they're opposite signs. One goes up, one goes down. That should make some sense. And then also they're reciprocal. So the 3/4 flipped would be 4/3. Okay? And so when we talk about parallel lines, they're the same slope. Perpendicular have to be opposite reciprocal. If our lines don't have one of those two, then it's considered to be neither parallel nor perpendicular. And so here's what we're going to do. We're going to take this problem. We're going to do two parts to it. I think that'll be kind of helpful to you. So the question says we're going to write an equation in both slope-intercept and standard form of the line that passes through the point 2, -4 and satisfies the given equation. And so it says that the line needs to be, for part A, the first part, is that it needs to be parallel to this line that's given. And then the second part needs to be perpendicular to that line. So the very first thing we need to do is take this 3x minus 2y equals 5. And we need to find that slope. Because if the line's going to be parallel to it, then we need to know what that slope is so that we can use the same slope. If it's going to be perpendicular, we need to know what the slope is so we can do the opposite reciprocal. And so, back a few slides ago, I think in the previous video, we talked about how to find the slope from this form of our equation, if it's in standard form, without having to necessarily solve for y. And so what we said is that we can take a -a, so in this case, the 3 is our a, divided by b, which in this case is -2. And so when you simplify that, you find out that the slope here is 3/2. Now, that is a big part of solving this equation. Now, what you'll see a lot of times is people will take this equation and solve for y. And I can promise you that if I'm not sure exactly how we're going to test yet, but when I give you your test or your assessment, if I do multiple choice, this equation solved for y in the slope-intercept form is going to be an answer choice. And that is absolutely not the correct answer. Because if you take that equation and rewrite it in slope-intercept form, you didn't write an equation. You rewrote an equation. You didn't write a new equation. And so we have to make sure we understand what the question says. So our question says we're going to take an equation that goes through this point to -4 that is parallel to this line that's given. Well, we just found the slope of it. We said it's 3/2. And so using our point slope form, we'll take this point and now this slope that we have, and we'll substitute it in. And so we have y minus the y coordinate, which is -4. And that's equal to 3/2 times x minus the x coordinate, which is 2. Now, it says to put our equation in both slope-intercept form and standard form. Excuse me. So, if we do that, we can very, very easily put this into either of those forms. First thing we're going to need to do, no matter what, is change that minus and negative to a positive. And we also need to distribute. Now, I'm going to go ahead and move this to standard form. And so, I'm sorry, to slope-intercept form. So distributing is what we would need to do here. So I'm going to take that and rewrite it as x plus 4 equals 3/2x minus 6/2. Well, 6/2 we know is 3, right? So I'm going to actually erase that and put 3, just so we make sure we have enough room here. So somebody says, well, how'd you get that? Again, out to the side, if you need to take 3/2 and multiply it by -2/1, if you multiply straight across, you get -6/2, which is -3. That's where that number comes from. And so then we need to take that 4 and move it over, so we'll subtract it. And we'll find out that y is equal to 3/2x minus 7. And so there is our slope-intercept form of our equation. Now, it also asks us to take that and find the standard form. So we can take this equation and rewrite it. So y plus 4 equals 3/2 times x minus 2. And if you remember, to put it in standard form, we need to multiply everything by the 2 because we got to get rid of the fraction. And so multiply the y by 2 and the 4 by 2 and then this fraction by 2 as well. And so when we do that, we're going to get 2y plus 8. And then this 2 we multiplied by and this 2 on the bottom of this fraction, they're going to cancel out. It's going to leave us with 3 times x minus 2. And then we'll distribute the 3. So we'll have 2y plus 8 equals 3x minus 6. And then we need to get everything moved, or the x and y moved to the same side and constants moved to the other side. And so we're going to subtract 3x. And in the same step, I'm going to subtract 8. That way everything gets moved to the same side. And so we have -3x plus 2y. The 8 minus 8 cancels. The -3x, or 3x minus 3x also canceled. -6 minus 8 is -14. Now, the problem with that is it's not in standard form because that first number is negative. And so we need to change the sign of everything, essentially multiplying everything by -1. And it makes it be 3x minus 2y equals positive 14. So there is our standard form. Okay, so that's the first part of this question, the parallel part. Now, if you were to take this equation, change color so I can guide where you're looking. If you were to take this equation and you were to solve for y, what you would notice is that in the slope-intercept form, it's y equals 3 over 2x and then some stuff. Well, that 3 over 2x is the same 3 over 2x that we have here, and that is going to be that's going to be an indication that those two lines are parallel because they're going to have the same slope. But this equation here is not the same equation as this one. Okay, and so make sure you understand that we're only using that equation given to find the slope. That's the only purpose of it. And then we use that slope and our point to write our equation. Now, in the second part of this, because we're going to do the same thing but with the perpendicular line, the slope we're going to use, because we already found it in the previous part, we're going to use the opposite reciprocal slope. So taking this 3 over 2, changing its sign and flipping it, it becomes negative 2 over 3. And so that is the slope we're going to use when we write our equation. And again, we're going to do standard form and we're going to do slope-intercept form. So if we take, that point and slope and put it into the point slope form, we're going to have y minus negative 4 equals negative 2/3 times x minus 2. And again, that minus and negative makes the 4 positive. And again, we can go to either one. So I'm going to go to standard form first. And so what we'll do here is multiply by 3. That way we get rid of the fraction. And when we do, it's going to give us 3y. That 4 times 3 is 12. It is a positive 12. And then this 3 we multiplied by, and this 3 on the bottom of that fraction cancel out. It leaves us with negative 2 times x minus 2. And then again, we need to distribute. And so we're going to get 3y plus 12 equals negative 2x plus 4. And then we need the x and y on the same side and constant on the other. So we're going to add 2x. And so we get 2x plus 3y. I'm also going to subtract 12 in the same step. That way 12 minus 12 cancels. The negative 2x plus 2x canceled. 4 minus 12 is negative 8. And so that one is now in standard form. So that's the first part of that one. And now the second part of that is to write that equation in slope-intercept form. And so what I'm going to do is just use that same equation. So it's y plus 4 equals negative 2/3 times x minus 2. And then again, I told you when we go to slope-intercept form, there's only 2 steps left. We're going to distribute and we're going to move the 4. And so when we distribute, we're going to have x plus 4 equals negative 2/3 x plus 4 over 3. Now, somebody says, well, how do you get 4 over 3? Well, again, if you need to take the negative 2/3 out to the side and multiply it by negative 2, again, we multiply straight across, we get 4/3. Okay, so that's how we get this number. Now, the last step to get this in slope-intercept form is solve for y. And so we're going to subtract 4. That way the 4's cancel, and we get y is equal to negative 2/3 x. Then we have this other number, this negative 4/3 minus 4. And this is where people tend to freak out. So if you can't do that in your head, and you don't know how to do it by hand, use your calculator. So here's what's happening. You're taking 4/3 minus 4. Well, that 4 is 4 over 1, and we need that 4 to be a fraction with the denominator of 3. And so to do that, you'd have to multiply 1 by 3, so you multiply the negative 4 times 3, and you get negative 12. Well, now negative 12/3 and 4/3 can be combined. Combining what's on top, keep the denominator on the bottom, so 4 minus 12 is negative 8 over 3. And so there is now our final answer. Now, what you may have noticed, if you were to go back and look at the standard form here, we talked about if we had our equation in standard form, well, we could find the slope and the y-intercept pretty easily, right? Negative a over b being our slope, so negative 2 over 3, which is what we had here. And then our y-intercept being c over b, so negative 8 over 3, which is what we had there. And so that would be another way that you could do this. I don't typically teach it that way because there's some memorization that has to happen. From an algebraic standpoint, what I've done here is the way to solve. And so that does wrap up chapter 2. Our